Okay, and welcome back for another part of stoichiometry. We're going to look at a couple of basic stoichiometry problems where we're trying to find out how much of a product are we going to get based off of the mass of the ingredients, the reactants. So we're going to be in the ammonia making business. So we're going to have our equation here. All right, so this is the equation that we're going to start out with. Now, typically, we are going to have, we need to know how much product we're going to make. So we don't know what that is. And in this case here, well, we're a little stingy. We got 2 grams of hydrogen gas. And, well, let's face it, nitrogen is so much of it in the air. We have something called excess. Now, excess means we have more than enough to make this reaction happen. So that means one of the reactants is going to run out. What is going to be our limiting reactant? Well, that's going to be the hydrogen, because the hydrogen is going to run out first. Okay, how do we go about solving the problem? Well, the first thing that we've got to look at, we have to be able to go from grams to moles here. So we need to go grams of H2 to moles of H2. Now, why in the world would we need to do that? We cannot take the mass of hydrogen and compare it to the mass of the ammonia. We can't. We have to change that from mass into moles. In other words, a mole is a number. So we have to change it from mass into numbers. Numbers of hydrogen tells us how many numbers of ammonia we're going to get, in this case, moles, and then we can change the numbers of ammonia into a mass, so we know how much we're going to actually get. So this is it, grams to moles of hydrogen. And oh wow, how in the world are we going to do this? Well, remember, we're going from grams to moles. So in the previous video, we talked about how to work that. Well, you're going to divide it. So we're going to make this very easy. We're going to say hydrogen is 1 gram per mole. Okay, and okay, so we have 2 hydrogens here together. Notice we're not doing the 3. The 3 does not enter into this. Just the H2, that's all we're interested in. Okay, so in this case here, I've got 2 grams, and I've got something here that's got 2 hydrogen atoms. Each hydrogen atom is 1 gram per mole, so it's going to be 2 grams of hydrogen divided by, well, 2 grams per mole of hydrogen. Okay, and we're going to get ourselves 1 mole of hydrogen gas. So that's how much we're actually getting in here. It's not much, in all honesty, but the idea is to show you how this works. Okay, now that we know the numbers, which in this case are moles for hydrogen gas, we've got to look at how do we change that from numbers of hydrogen to numbers of ammonia. That's the key. And that's where those coefficients are going to come in play right here. That's where they're going to come in play because there's a ratio. Think of it, 4 regular tires to 1 car. Think about it that way. So in this case here, 3 of these H2s, and we get 2 NH3s out of the deal. Okay, remember, nitrogen is excess, so we don't care. So we're going to go in 1 mole of H2. We have no idea how many moles of NH3 we have, but we do, that's what we have, but we have a ratio, and that ratio is 3 hydrogens for every 2 ammonias. Okay, so that's going to be 3 hydrogens for every 2 ammonias. So that's the key thing here. Now, does it matter which one you put on the top or the bottom? No. No, it doesn't. Okay, but the important thing you have to remember that you're setting up a proportion, a ratio. Okay, and in this case here, we've got 1 mole of hydrogen, 3 moles of, and it's a 3-to-2 ratio. So when we go and look this over, we can cross multiply and divide. So we can say 2 times 1 is equal to 3 times x. Solve for x. Okay, so we'll go 2 is equal to 3x. Therefore, x is going to equal 0.67 moles of ammonia. So that's how many moles of ammonia that we have. We're good to go on that. So now we've done the second part. We figured out in the first part, which I did in red, we had to figure out how many moles of hydrogen, think numbers, of hydrogen based off of the grams of hydrogen that we had. We calculated that out to be 1 mole of hydrogen gas. Then we come down here in our second step, we had to look at the moles of hydrogen to moles of ammonia that we are getting. So we're changing it from numbers of hydrogen to numbers of ammonia. Remember, a mole is a number. Think dozen. It's a chemist's dozen, if you will. Now we figured out what's our number of ammonia. Now we can figure out the mass. That's our last step. I'm going to go ahead and do that one in blue. And you'd say, well, wait a minute. How do I know about the mass of the ammonia? Well, we're going to make this easy for us. Okay? We have an NH3. And we're going to say N is 14 grams per mole. And each of the hydrogens is 1 gram per mole. So we're going to make this easy. 14 plus 3 is equal to 17 grams per mole of ammonia. All right. Now they told us we have basically 2/3 of a mole of ammonia. So we just multiply 0.67 moles multiplied by 17 grams per mole of NH3. Because what are we doing? We're trying to find how many grams of ammonia we have. But we have to cancel out the moles. And in this case, we're just going to multiply straight through, and the moles will actually cancel each other out. And our final answer, ladies and gentlemen, our final answer is 11.39 grams of NH3 are going to be produced as a result of this reaction. Okay? This is one way of looking at solving a stoichiometry problem where you have the reactants, you have an excess amount of one reactant, a limited amount of the other. So let's go back. We have our original equation here. We had an excess, we had 2 grams, and we had how many grams of NH3? We're not sure. Our first step, we got to change this, our hydrogen, from grams into numbers, and that's moles, okay? Because a mole is a number. Think chemist dozen. So we go from grams to moles, well, we're going to need to divide, and we had to figure out how many grams there were in a mole of H2. We said H was 1 gram per mole for simplicity's sake. So 2 grams of hydrogen divided by 2 grams per mole gave us 1 mole of hydrogen gas. Then we went down in our second step, which I did in the green. Great, we've got 1 mole of hydrogen gas. How many moles of ammonia are we getting? So we're going to look at the number of moles of hydrogen, and we're going to get the moles of ammonia. If I have 6 dozen tires, how many cars can be completely outfitted with 6 dozen tires? That's my analogy. And we looked at the ratio here, the coefficients that we found in the original equation here, 3 hydrogens to 2 ammonias. So we look at that here, 3 hydrogens to 2 ammonias, okay? And remember, the hydrogens need to be on the top. You can't put it here on the bottom because that will mess everything up. Pay attention how I set this up, okay? All right, so then we went ahead and we cross-multiplied because this is a proportion, and we solved for x, and I showed you down here, and x was 0.67 moles of NH3. Then our last step was, okay, now we have the number of ammonia, the moles of NH3. How much does it weigh in grams? That means we would go from moles to grams, which we multiply. In this case, we have 0.67 moles. But in order to figure out how many grams there are in a mole of NH3, we had to figure out 14 for the nitrogen, we're keeping it simple, and 3 hydrogens. So we added those up. That's 17 grams per mole. So 0.67 times 17 gives us our final answer of 11.39 grams of ammonia being made in this particular reaction. Hey, I hope this will help people out. I will see about possibly doing some others at a later time, covering excess reactant, not excess, but limiting reactant. Okay? Hey, take care and have a good one, guys.